Okay, I'm going to start back a little bit with some basic negative fraction help. So k to the negative 5, we know because we have a negative sign in the exponent, we take the inverse. So essentially we have to flip this fraction and we keep the exponent. So it's 1 over k to the 5. And then we also know that in the case where the negative exponent is in the denominator, we have to take the inverse again and have b to the 4 over 1, which is equal to b. Okay, oh sorry, excuse me, which is equal to b to the 4, but you don't have to have the 1 under it. So we know these kind of two basic things. When you have a negative exponent in a standard number, you flip it, so you're taking essentially the fraction, the fraction form, it's called the inverse, where, and the reason why it's called the inverse, you know what, I need to tell you that. The reason why it's called the inverse, let's say we have x to the negative 1. The inverse of x, pretend like x itself is just over 1. The inverse of x is 1 over x, because if you multiply these two numbers, you get x over x, which is basically the same thing as 1. So the inverse relationship is anything that would, when multiplied against the original, create a 1. So back to k to the negative 5, I have to use the inverse of k to the 5th, which is 1 over k to the 5. And all that negative sign is telling me is, hey, take the inverse. We also used a funny comparison in class today, which might help you remember. We said this little negative sign is like an airline ticket to the other side of the division sign. So we know there's an imaginary division sign really with any whole number. We can put any number over 1. So that's where this comes from. That's where 1 over k to the 5th comes from. Okay, and then if this is 1 over b to the negative 4, well, the inverse of that, the inverse of 1 over b to the 4th is b to the 4th over 1, or b to the 4th. Okay, a simple way to look at it, you just flip it to the other side of the division sign, and a tricky way to look at it, which might help you conceptually, is to think of this. To think that you need to find that inverse, or whatever the thing is that creates a 1. Okay? Okay, so let's try this one. Negative 2g to the negative 2 is tricky also, because here's a negative sign for a number. That means that this is on the negative side of the number line. All that negative sign means is that if this is 0, this number here is negative 2, okay? Or the opposite of positive 2. If positive 2 is here, then negative 2 is the opposite, okay? And then this negative here means, hey, take the inverse of g to the 2, right? So what we do when we simplify this is we need to basically get any negative exponents settled so the exponent, the exponential number, is in its proper place. So negative 2 is going to stay the same. Actually, let me go back. Let's put this whole thing over 1, which we can do because it is a whole number. It's two whole numbers. So now we can think of it as being on one side of the division sign. So negative 2 g to the 2 is the same as g to the negative 2 is the same as negative 2 over g to the 2. So I basically took this number here and moved it to the other side of the fraction line. And this here, the 1, is understood. So this 1, we don't have to write it anymore once there's another number or variable on the bottom of your fraction, because it's understood that it's 1g to the 2nd. Okay, so that's a very basic, very conceptual understanding of negative exponents, and I'm going to follow up with more specific examples.